Welcome to this video on simplifying radicals. A little bit of vocabulary before we get started. A radical is this symbol right here. Sometimes you might have called it a square root, but its official name is a radical. The number underneath your radical is called the radicand. And our final piece of vocabulary is there's a number that sometimes sits on the shelf. Sometimes you'll see maybe a 3 or a 4. That number is called the index. Sometimes you see a radical with nothing on that shelf, no number at all. If there is no index, that is, the number is assumed to be a 2. And we'll be talking about square roots, which is the limit of our notes today, is square roots. Okay. So one thing I want to prepare you for as we move forward, if you can remember your perfect squares, it helps simplifying a little bit. It makes it a little bit easier. A perfect square is a number times itself. So for example, if I took 1 times 1, 1. So 1 is a perfect square. 2 times 2 is 4. So 4 is a perfect square. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. 10 times 10, 100. 11 times 11, 121. And 12 times 12, 144. So when you start to break down these numbers, if you hit a perfect square, it'll be easier to recognize the pattern and you'll save yourself a little bit of work. So our first example here is the square root of 80. I just asked you, what is the square root of 81? A bunch of you would just say 9, but you may not really know why. And here's why. 81 can be made by taking 9 times 9. When we're working with square roots, remember it's really a 2 that is the index. That means I need 2 of the same number to take it out from under the radical. I have 2 9s, which means I can take 9 out from underneath the radical. In this case, there's nothing else left. That's what it means to be a perfect square. The square root of 81 is 9. Let's look at our second example. This one's a little different. It says 3 times the square root of 144. So we have a coefficient here, and here's how we're going to deal with it. 144 we just talked about. It can be found, one of the ways we can break it down is 12 times 12. I'm suggesting we use our perfect squares when we can. I have a pair. That's what my index says. I need 2 of the same number for it to come, one of them to come out from underneath the radical. There's no other numbers underneath the radical, but what about that 3? What do I do with that? Anytime you have a coefficient, it comes down and still has to be part of the answer. When I have multiple things coming out on the outside of the radical, I'm going to go ahead and multiply them together. 3 times 12 is 36. So I'm just going to show you on my calculator. Shortcut, 3 square root 144 will simplify down to 36, which is the exact same answer we got. All right, let's try it with 289. Now, I didn't take you up to 289. I didn't tell you that number. So how do you figure out if a number is a square root? To check easily, we can do second x squared to get our radical. And let's put 289 in there. And it says 17. That means 289 is gotten by taking 17 times 17. Our index of 2 means we need 2 of the same number for one of them to come out from underneath the radical. We have a coefficient right here. He needs to come down. And remember, anything that's brought down on the outside together, we're going to multiply together. So we're going to do 4 times 17, and we get 68. One last one on our perfect squares. Then we're going to make it a little bit different. So we have second x squared. I'm going to put 400 in there to see if it's a perfect square. It is 20. See how it's a nice, pretty number? That means this is 20 times 20. My index of 2 says I need 2 of the same number for one of them to come out from under the radical. I have a coefficient that I have to remember to bring down. And that is all that I've got left. 5 times 20 is 100. So you might be thinking to yourself, why wouldn't I just put 5 square root 400 into the calculator and get my answer? Well, the quick response to that is they don't always turn out to be pretty numbers. Let's take a look on the back here of your notes. So I have an example here, 32. So when I look for the square root of 32, it's not a pretty number. That means that's not a perfect square. And I don't want to get my simplified radical into this form. I want to write it in a different form. So that's what I'm going to show you how to do. So we're going to use, I'll give you a quick reminder of what to do up top. Use your prime factorization to reduce the radicand. Prime factorization is finding the prime numbers that multiply together to make the original number. So we're really just going to be breaking down the number. Look for pairs of the same number. That means they can come out. Move any paired number to the outside, but we're going to leave unpaired numbers under the radical. And then we simplify by multiplying. So let's take a look here. So 32, we know it's not a perfect square. We could multiply different pairs of numbers to make 32. You can do 1 times 32. You can do 2 times 16, 4 times 8. And I think that those are all our possibilities. I'm going to use the 2 times 16. You could easily use 4 times 8. Don't ever use the 1 times number. That doesn't work for what we want to do here. So let me show you. 2 times 16. 2, the only way to get to 2 is 1 times 2. That's a prime number. We are done here. But we want to start breaking down the 16 further. We saw in the front 16 is 4 times 4. So I'm going to cross out the 16. I have a pair of 4s. Do you remember what that means? Look for pairs. Move paired numbers to the outside. So the 4 is going to come out from under the radical. But what about this 2 right here? Does the 2 have a pair? There is not another 2 here. Leave unpaired numbers under the radical. So I'm going to put a radical here, and that's where that 2 is going to go. I've accounted for every number that's broken down. My answer is 4 root 2. So here is that ugly decimal. If I go ahead and put 4 square root 2 in my calculator, I got the same number. So what you're doing is you're just rewriting the number in a different form. Okay, simplest radical form. So let's look at 180 and try it. Square root of 180. So we could do 2 times 90, 3 times 60. You can do any of these pairs. Any of them will work. And so I can do 180 divided by 4. Does that work? Yes. 4 times 45. 180 divided by 5. I'm just looking for anything. 5 times 36. Any of these pairs will work. It does not matter which one you use. I'm going to use the 5 times 36 because I want to for no other reason. 5 times 36. Okay. 5 is a prime number. The only way to get it is 1 times 5. So that's not going to break down any further, but 36 can be broken down to 6 times 6. What am I needing to look for? Pairs. I have a pair of 6s. What does that mean? A 6 comes out from under the radical. What about this 5? There are no other numbers that got broken down, so the 5 goes back in the radical. And 6 square root 5 is the same as the square root of 180. It's just written in a simpler form. All right, let's keep trying a couple more. This would be a really good place to stop the video ahead of me and try them and come back and see how you did and check with me. Square root of 147. I don't know what goes into 147. It's not even, so it's not 2, so I'm going to try a 3. 147 divided by 3 goes in 49 times. That works. 3 times 49. Okay, 3 is prime. It's not going to go any further, but 49 gets broken down. We use the 49. We just rewrote it as 7 times 7. I have a pair of 7s. That means a 7 is going to come outside of the radical. Unpaired numbers are left under the radical. Okay. Let's try number 4. 175, it ends in 5, so I know it's divisible by 5, so I'm going to just try that one. 5 times 35 works. 5 times 35. 5 is a prime number. I'm not going to take that one down any further because I can't. 35 I can get by 7 times 5. I like to cross those out to know I've already used it. 7 and 5 are both prime numbers. They won't break down any further. So when I look for pairs, I see there's a 5 and a 5. It doesn't matter that the pair is not side by side. We're looking for 2 of the same numbers. That means a 5 is going to come to the outside. And this 7 right here is unpaired, so he remains under the radical. Okay. 2 more. Square root of 48. Off the top of my head, this was always a hard number for me growing up. 6 times 8 is 48. That's how I always remember it, so that's the pair I'm going to use. Neither one of those is prime. They'll break down again. 6 is 2 times 3. And 8 is 2 times 4. And 4 will break down one more time to 2 times 2. All right, I got a little bit of a mess here. Let's take a look. I got a pair of 2's, so I know a 2 will come out. If you look, they're not side by side, but I do have another pair of 2's, which means another 2 will come down. And remember, we're going to multiply anything that gets taken out together. And then I have this 3 who's all alone, which means he's got to go back under the radical. The final step is to simplify by multiplying. 2 times 2 is 4, and then the root 3 stays the same. All right, one last example, and you can go do your practice assignment. This one has a coefficient, so I'm just going to remind you, bring the coefficient, and it's going to... All right, so remember, whatever's on the outside, you're going to multiply it to whatever else comes out. 54. How do we make 54? It's even, so I divide it by 2, and I got 27. So I'm going to break that down to 2 times 27. I've rewritten 54, so we can't use it anymore. 27, 2 is prime, so we cannot break it down anymore. 27 can be 3 times 9. 3 is prime, so we're not going to break it down anymore, but 9 can be broken down to 3 times 3. Look for your pairs. I have a pair of 3's, so I'm going to bring it over here, 2 times 3. But what about these guys right here? I have a 3 that does not pair up, and I have a 2 that does not pair up. Remember, it says any unpaired numbers can put back under the radical. So I'm going to put my radical, and I had a 2 and a 3. What do you think we do with those? What did I do with the things out here? I multiplied them together, so I'm going to do the same thing on the inside too. Anything that gets put back together, because we were really dividing to get these numbers, you multiply them to put them back together. I end up with 2 times 3, which is 6. Square root 2 times 3, which is 6. Hopefully this is helpful for your practice. If you have trouble, be sure you come back to watch the video.